Hello friends, welcome to Vidyunmala. In this video, I am going to deal with some basic concepts of electrochemistry. Intended audience for this particular topic is +2, Bachelor of Science, Master of Science, and anyone interested to learn, they can join us. So, to start with electrochemistry, we have to learn some fundamental definitions. Let's go first. Then the first question is, what is electricity? Mostly whenever I ask this question to my students, the answer is like flow of charge of rate of current. I never understood what exactly the definition was. But electricity simply, it is a form of energy. That's it. So electricity is a form of energy. Then what is electric current? Electric current is the flow of electric charge, maybe electrons or ions. Electrons in the case of metal wire, ions in the case of an electrolyte. We will learn what electrolyte is. An electric conductor is any substance which allows electric energy to pass through it. Mostly we come across with a wonderful word called conductor. Conductor is any substance that allows energy to pass through. See, if you are listening to me, you are a conductor. You are allowing my sound energy to reach you, to pass through you. So you are a conductor. So conductors are generally of two types, as thermal and electrical. So electrical conductor is the one which allows electric energy to pass through. Then the thing is resistance. What is resistance? The electrical resistance of any conductor is a measure of the difficulty to pass an electric current through the conductor. Say for example, you are listening to me, you are listening to my class, something resists you from listening, something will stop you from listening, or some way you feel difficult to listen to me because in the television you are listening to my lecture in your mobile phone. In the television there was a wonderful song which you love to listen. So that song is going to resist you from listening me. So that is what we call as resistance. Resistance means prohibit, stop, or non-allowance. So electrical resistance is the difficulty to pass electric current through it. Then electric conductance is defined as a special property of a conductor which determines how easily current can pass through it. So if you are listening to my class, how easily my class is reaching you, that is what you call as conductance. If you are not able to grasp it easily due to some factors, you call it as resistance. And if you are easily grasping my lecture, you are a wonderful conductor of my lecture. So let us take a piece of conductor of length L and cross-sectional area A. Then what happens is resistance offered by that conductor is proportional to length and inversely proportional to cross-sectional area. So length R is proportional to L, R is proportional to 1 by A. So then R equal to rho L by A, where rho is called as specific resistance or resistivity. Rho is called as specific resistance or resistivity. So as mentioned earlier, R is equal to rho L by A. So resistance equal to specific resistance multiplied by length of the metal wire divided by cross-sectional area. When temperature is increased for a metallic wire, the length increases, cross-sectional area decreases, and hence resistance increases for a metallic conductor. So on. What is conductance? As we learned in our previous video, conductance is nothing but the property of allowing something to pass through, property of current to pass through. Otherwise, conductance is the reciprocal of resistance. Okay, then 1 by R, that is equal to Z, equal to 1 by rho L by A. So you will get rearrange the equation. So Z equal to sigma A by L, where G is conductance, sigma is specific conductance or conductivity. Specific conductance or conductivity. So if you want to calculate specific conductance, that is sigma equal to G multiplied by L by A, and this L by A is called as cell constant. this L by A is called as cell constant. It has units like centimeter inverse, because units for length is centimeter and units for cross sectional area is square centimeter. They get cancelled off. You get centimeter inverse as the units for cell constant. Then the last term to be learned in electrochemistry is electrolyte. We often listen this word in summer, during summer, because we get dehydrated. We will be suggested or advised to take electrochoice or electrol or electrolyze. All these are a simple chemical compound. When they dissolve in water, they get dissociate into their ions. So electrolyte is defined as any substance in aqueous solution or in molten state. They get dissociate or ionize into their ions. For example, sodium chloride, potassium chloride, hydrochloric acid, sodium hydroxide, etc. Then it comes for what exactly electrochemistry that stands for. Simply to make you understand, electrochemistry is the branch of science that deals with the mutual conversion of electrical energy into chemical energy and chemical energy into electrical energy. In the first diagram on the left hand side, you find two beakers. One of the beaker is filled with aqueous zinc sulfate solution in which zinc rod is immersed, and in the other beaker it is filled with aqueous copper sulfate solution where copper rod is placed. To make you understand in a better way, I have taken this example because aqueous zinc sulfate is colorless, aqueous copper sulfate is blue in color, copper rod always appears to be brown in color, zinc rod is in gray color. When these two beakers are connected through a salt bridge, I will let you know what exactly salt bridge is in another video. Then when the two rods are connected to a voltmeter, then suddenly we find a deflection. What do we mean by the word deflection? Deflection means change in the value. Okay, what had happened we will come to know in a few minutes from now. In the second example on the right hand side, I have taken a single beaker in which I placed some salt solution. Two electrodes or two rods were immersed. These two rods were connected through a battery. It would have been learnt by you in your previous classes in maybe in 7th, 8th or 9th. And what had happened here? So one of the electrodes or rod get deposited by the metal ion. This particular science is called electrochemistry. On the right hand side, electrical energy is being utilized to make a chemical reaction happen. On the left hand side, chemical reactions produced electrical energy, that is current. So chemical reactions producing current on the left hand side. Current is being utilized to make a chemical reaction happen. This combinedly is called as electrochemistry. What exactly the reactions involved in this particular process are called as? They are called as redox reactions. They are called as redox reactions. We will let you know in another video. Then, whenever we take a salt, say for example sodium chloride, when sodium chloride is placed in distilled water, it dissociates into its ions Na plus and Cl minus. See, why can't we use the word ionizes? Because in sodium chloride crystal, the ions exist as ions. Sodium ion bound by 6 Cl minus ions. Each of the Cl minus ion bound by 6 sodium ions. So they exist themselves as ionic in solid state. When it is dissolved in water, they exist as ions only, but they got dissociated. Whereas you come for the bottom diagram, I have taken water in a beaker in which I placed hydrochloric acid. Hydrochloric acid in liquid state, it is a covalent molecule. When it is added to water, it gets ionized to H3O plus ions and Cl minus. So in the original state, sodium chloride, the substance exists as its ions only, whereas in case of HCl, neutral molecule getting converted to ions. So that is the difference between dissociation and ionization, which we learned previously in electrolyte concept. Why I placed here? Because the next concept is Arrhenius theory of electrolytes. To know it, we have to understand what exactly dissociation and ionization that takes place. Then The property of conductor which facilitates to flow electricity through it is called as conductance. That's what we studied previously, no? So electrolytic conductance, I was talking about metallic conductance in my previous words. Now it is electrolytic conductance. Electrolytic conductance is offered due to ions, mobility of ions, movement of ions. This falls into three categories. One is specific conductance, equivalent conductance, and molar conductance. So what do you mean by specific conductance? The name itself indicates specific. So simply conductance offered by all the ions present in a specific volume. Say for example 1 cc volume. How many ions will be there? Say for example 10. So that conductance called as specific conductance. Remember, specific conductance is the conductance offered by all the ions present in a fixed volume. Say your classroom volume is fixed. How many ions are there? Say for example your classroom strength is 30 students are there. 30 ions will move. They move around. So such conductance is exactly known as specific conductance. It is denoted by a letter called kappa. Okay, and then second one is equivalent conductance. It is the conductance offered by all the ions produced by 1 gram equivalent of electrolyte. So you have to take here into account 1 gram equivalent. Then it is called as lambda equivalent. Molar conductance same, 1 gram mole of the substance, 1 gram mole of the electrolyte. Specific conductance only, the volume is fixed. But in case of equivalent and molar, the weight of the substance is fixed. In case of equivalent, it is 1 gram equivalent. In case of molar, it is 1 gram mole of the electrolyte. Then you could find here why I am stressing specific conductance, because it is playing an important role in chemical sciences. So here I have taken 1 centimeter cube of some place. In that place, some ions are there, and the conductance offered by the ions present in this particular area or in this particular volume is exactly called as specific conductance. The units are ohm inverse, centimeter inverse, otherwise mhos per centimeter, otherwise Siemens per centimeter. Now here, what are the factors that influences specific conductance? The factors that influence specific conductance are temperature, number of ions, size and charge of the ion, concentration or dilution. Say, how do temperature influence? Because as I said, electrolytic conductance is the conductance offered by the ions. So in a solutions, ions are moving. So when temperature is increased, the average kinetic energy increases. The ions are moving, the average kinetic energy increases. Say suddenly you are in the class and you are wandering around, and there suddenly somebody says college is holiday for now. So automatically what happens? That is a temperature. Temperature has been increased. You all make more noise. So you move here and there. You make all nonsense, no? So when temperature is increased, specific conductance increases. Number of ions. More the number of ions, more will be the conductance. Size and charge of the ion. See, remember, a lean person is there and a very fat person is there. Who will run fast? Undoubtedly the lean person will run fast, because his size is less. So smaller ions will have higher specific conductance. For example, hydrogen. What is its atomic number? 1. Electronic configuration 1s1. H plus ion, it is having very least size. So the specific conductance offered by the H plus ion will be the highest. Coming to concentration or dilution, say you are in a classroom. For example, in your classroom 30 students are there, and your classroom has a door at the end. Suddenly what had happened, one student didn't like to listen to the class. He wished to close it there. He want to go away. So what does he do? He will just open the door very calmly and quietly, and he skips away. That fellow goes out. He stays out. He will not stay quiet and calm, no. Then he will be calling the other boy. You come out. How much you listen to that dirty lecture? Come out. So the other boy will go. What is the total strength? 30. Now when the door is opened, what is the volume of your classroom? the classroom volume is increased, your volume of the classroom is increased because the door is open, no, then volume increased. So when volume increases, number of ions will be decreased. Number of ions decreased, specific conductance decreases. When the number of ions decreases, specific conductance decreases. So increase in volume in chemistry, it is called as dilution. Increase in volume in chemistry, it is called as dilution. So on dilution, specific conductance decreases. Remember this word for every time. On dilution, specific conductance decreases. So equivalent conductance, it is defined as already defined in my previous slide. So 1 gram equivalent. So lambda E equal to K into 1000 by C. Lambda E equal to K into 1000 by C, that is equal to K into 1000 by M, molarity, if you are talking about molar. Then the units are ohm inverse, centimeter square, gram equivalent inverse. The same expression for molar conductivity also, it is going to be lambda equal to K into 1000 by M. If it is gram equivalent weight, it is lambda equal to K into 1000 by N, normality. How did you arrive at this expression? It is very easy. Lambda E equal to K into volume. Lambda E equal to K into volume. From where we get volume expression? We get from molarity is equal to number of moles by volume. Number of moles by volume. So volume is equal to N by M, small letter n by M. So number of moles 1. So volume is equal to 1 by M. You could place it here and you will be obtaining.